Good morning to everyone. Myself Siddhamma MN, guest lecturer, Department of Physics, Kottureshwara College, Kottur. So in this video, I will explain about the electrical and thermal properties of materials for B.Sc. 6th semester students. So in this electrical conductivity of metals. So in metals, the atoms are so tightly packed that electron of one atom experience sufficiently significant force of other closed atoms. The result, the valence band and conduction band in metals come close to each other and may even overlap. In conductors, the conduction band and valence band are overlap. Consequently, by receiving very small amount of energy from external heat or electrical energy source, the electrons readily ascend to higher levels in the metals. In metals, the valence electrons from the valence band will move towards the conduction bands by applying the some amount of energy or electrical energy source. Such electrons are known as free electrons. So these free electrons are responsible for current that flows through a materials. Due to the presence of free electrons in metals, the current will flow in the metals. When external electric source is connected to a piece of metal, these free electrons start flowing towards higher potential terminal of the source. So if we consider a metal, if you supply some amount of external energy, so the free electrons will move towards the lower energy to the higher energy level. That means in valence band to the conduction band. So the current is flowing through in the metal. So in metal, the density of free electrons in conduction band is much higher than other materials. Hence metal is referred as very good electrical conductors. So it means the number of free electrons are maximum in conduction band or conductors. So number of free electrons are maximum in conductors, so that these are called as very good electrical conductors. In other words, electrical conductivity of metal is very good. That is, electrical conductivity of conductors is maximum, which means the ability to supply electric charge. So the diagram has shown that the valence band and the conduction band are overlap. So band gap means the gap between the valence band and the conduction band. So in metals, the valence band and conduction bands are overlap. So this is the conductivity of the conductors. So in conductors, the conductivity is maximum compared to the other metals because the number of free electrons are maximum in conductors. So next one, electrical conductivity of semiconductors. So in semiconductors, the valence band and conduction band are separated by a forbidden gap of sufficient width. Means in semiconductors, there is a gap between the valence band and the conduction band. At low temperature, no electron possesses sufficient energy to occupy the conduction band, and thus no movement of charge is possible. At room temperature, if any, at room temperature, no electron possesses sufficient energy. It means no free electrons having sufficient energy to occupy the conduction band, and thus no movement of charge is possible. But at room temperature, it is possible for some electrons to give sufficient energy. At room temperature, some free electrons have the sufficient energy to move from the valence band to the conduction band. So it is possible for some electrons to give sufficient energy and make the transition in conduction band. The density of electrons in conduction band at room temperature is not good as metals, but the density means the number of free electrons in semiconductors is minimum compared to the conductors. The electrical conductivity of semiconductor is not as high as metal but also not as poor as electrical conductivity. It means the electrical conductivity of semiconductor is low compared to the conductors and high compared to the insulators. So the conductivity of semiconductors lies between conductors and the insulators. So that is why this type of material is called semiconductors. Because of that we called as the semiconductors. The conductivity of semiconductors lies between the conductors and insulators, so that we are called as the semiconductors. So the diagram shows that there is a gap between the conduction band and the valence band. So that is the semiconductors. So in semiconductors there are two types, one intrinsic semiconductors, other one extrinsic semiconductors. So now we are called as the intrinsic semiconductors are the pure semiconductors, extrinsic semiconductors are the impure semiconductors. There are two types of carriers in the intrinsic semiconductors. So in the pure form of semiconductors we called as the intrinsic semiconductors. In that there are two types of carriers, that is electron and holes. Its specific conductance is sum of conductivities. So the conductivity of intrinsic semiconductors is the conductivity of the both carriers, that is sigma n due to free electrons and sigma p due to holes. The conductivity of the electrons and the conductivity of the holes. Thus the electrical conductivity of intrinsic semiconductor is sigma equal to sigma n plus sigma p, that is the sum of the electrons and conductivity of sum of the electrons and plus conductivity of the holes. So next sigma I equal to Ne mu e plus Pe mu e. For an intrinsic semiconductor, N equal to P equal to Ni. In intrinsic semiconductors number of holes equal to the number of electrons, so that we taken as N equal to P equal to Ni. Sigma I equal to Ni e into mu e plus mu p. For an intrinsic semiconductor, the number of charge carriers is given by n equal to n exponential into minus e divided by 2 kt. Here k is the Boltzmann constant and T is the absolute temperature. The equation describes the conductivity of extrinsic semiconductor. So the above equation sigma equal to Ni e into mu e plus mu p for intrinsic semiconductor. Similarly, the conductivity of extrinsic semiconductor is sigma I equal to Ne e mu e plus Nh e mu h. The only difference is that the number of electrons in the conduction band and the number of holes in the valence band are not equal in the case of extrinsic semiconductors. Means the difference between the intrinsic semiconductors and extrinsic semiconductor is, in intrinsic semiconductor the number of holes and the number of electrons are equal, but in extrinsic semiconductors the number of holes and the number of electrons are not equal. A typical plot of the log of conductivity against temperature is shown for both intrinsic semiconductor and extrinsic semiconductor respectively. So as shown in figure, log of sigma I versus 1 by T for intrinsic semiconductors, log of sigma I for 1 by T for extrinsic semiconductors. So in intrinsic semiconductors, log of sigma I increases if the temperature increases. So in extrinsic semiconductors, if the temperature increases, conductivity also increases. One particular value temperature decreases, the conductivity also decreases. So this is the conductivity of the semiconductors. So the conductivity of the conductors is maximum. The conductivity of the semiconductor is lies between the conductors and the insulators. So this is the conductivity of the conductors and the conductivity of the semiconductors. So thank you.